Hi, my name's Saditi. I'm a member of the Teen Advisory Board of Howard County Library System, and today I'm going to teach you all about polynomials and how to do grouping. Before starting this video, you will need to know how to factor binomials, the distributing property, and the basic exponent rules. Let's start by learning what polynomials are. The word polynomial consists of two words, many and names, or terms in this case. By definition, a polynomial is a set of a finite number of terms. Each term consists of a coefficient, a variable, and a degree, or an exponent. Let's say, for example, negative 2x plus 7. This is a polynomial with the highest degree of 1 as x is to the first power. 2x to the 15th power plus 9x to the 10th power plus 4x plus 5 is also a polynomial with the highest degree of 15. Although it seems like the degrees can go on forever, there are two limiting factors. The first factor is that the coefficient of every term has to be a real number. So it can be any number, but it has to be real. It cannot be imaginary. The second limiting factor is the exponent or the degree has to be a whole non-negative number. So say, for example, we have 9x to the 1/5 power plus 5. This would not be a polynomial because the exponent is not a whole number. It's a fraction. Well, then what about 5 root x? Well, this is kind of tricky. We know that the variable is x to the first power, which leaves x by itself. But it is to the root of 2. So we can put a 2 in place of here. Knowing our exponent rules, x to the power of a to the root of b is equal to x to the power of a over b, which is a fraction. So in this case, if we substitute a for 1 and b for 2, this is equal to 5x to the 1/2 power. And 1/2 is not a whole number, meaning this cannot be a polynomial. Now, let's get into grouping. Let's start with an example. 3x cubed plus 6x squared minus 4x minus 8. Okay, so as you can see, there are 4 different terms. There aren't 3. If there were 3, then we would use basic binomial factoring, but this requires for something different. And this method is called grouping. Now, before we do grouping, we have to check something. We have to check the ratio. This is the most important part when you're doing grouping. If the ratios do not match, then you cannot do grouping. How do we check the ratios? We take our first 2 terms and our last 2 terms, and we make sure that the coefficient of the first term divided by the coefficient of the last term and the coefficient of the third term divided by the coefficient of the fourth term are equal to each other. So let's explore this a bit further. Here we have 3 divided by 6, first and second, and negative 4 divided by negative 8, third and last. If we simplify these two, then we get 3 divided by 6, which is equal to 1 over 2, and negative 4 divided by negative 8, which is also equal to 1 over 2. Since the ratios are the same, we can proceed with this problem. Okay, so let's start grouping. The method for grouping is the same as the name states. We're going to group the first 2 terms and the last 2 terms together. Now, as we can see, there is a factor in each of these terms that we can distribute out of the binomial. So here we have 3 and 6. We can divide both of these coefficients by 3. And we have x cubed and x squared. We can divide both of these variables and degrees by x squared. So we're going to put this outside of our binomial. So here we have 3x squared, and what remains here is an x, and here we have a 2. So now This looks very similar to our original factors. Now, what about this? What would we take out of this? Well, this has a -4 and this has a -8. We can take out a -4 from here, but we can't take out any variable or any degree. So we're going to put -4 here, and this has x, and here we have a 2. Now, you can see that the binomials inside each of these terms are the same, x plus 2 and x plus 2. This would not have been possible if our ratios were not the same. That's why we always need to find the ratio before we start grouping. Now, the next step is very simple. We take our distributed factors and we combine them. So here we have 3x squared plus -4, which is also -4. And this will be one binomial. And we take our x plus 2 and x plus 2, and we're going to combine them to 1 since they are the same binomial. So here we have x plus 2. Now we have two binomials, and to solve this equation, we have to equal them to 0 so we can solve for x. So 3x squared minus 4 is equal to 0. And here we have x plus 2 is equal to 0. X is equal to -2. And x squared is equal to 4 over 3, meaning x is equal to plus or minus. Remember, when you're rooting both sides, you have to do plus and minus. 2 over root 3. And these are our solutions. Here we have 3 solutions. We can tell that the number of solutions for this equation is 3 by checking the highest degree of the polynomial. Since the highest degree is 3, we know that there have to be 3 solutions, and as they are, this is correct. Let's try an example. 21x cubed plus 14x squared minus 15x minus 10. Pause this video and try it on your own, and then I'll show you how to do it. To solve this problem, we will follow a set of 5 steps, similar to how we did it for the last problem. So the first and most important step is to check for the ratios. We cannot move on without checking for the ratio. So here we have 21 divided by 14, which is equal to 3 over 2, and -15 divided by -10, which is also equal to 3 over 2. Since the ratios are the same, we know that we can proceed with this process. Okay. Step 2 is to group them into sets. So we're doing nothing, but we're just putting parentheses around the first 2 and the last 2 sets, like so. Step 3 is to take out common factors. So here we have 7x squared, which is a common factor of this set, and -5 for this set. We can see that the binomial inside are the same, which makes sense because our ratios are the same. Okay, step 4 is to combine our factors and take our binomials as 1. So we're going to count 3x plus 2 and 3x plus 2 as 1. So we bring this down here, and we're going to combine 7x squared and -5. So we have 7x squared minus 5 and 3x plus 2. Step 5 is to solve for x. So 7x squared minus 5 is 0. Through this process, we get x equals, don't forget the plus or minus the square root of 5 over 7. Now, if the problem asks for it, you will need to rationalize, but for now, we will just leave it as it is. And here, 3x plus 2 is equal to 0, and x is equal to -2 over 3. Here we have 3 solutions, and the highest degree of our polynomial is also 3, so we know that this is correct. In this video, we learned what polynomials are and some examples of polynomials, some limiting factors which state whether a polynomial is classified as one or not, and examples for that as well, and how to do grouping with a set of steps. Thanks for watching, and I hope this video helped.